Okay, hi everyone. So my name's Ed Seymour. I'm from Red Hat. So I've got quite a prosaic title for my talk there. I'm actually going to talk about containers, Docker, and Kubernetes, and really how you can leverage that technology to improve like software development life cycles. So as an example, I'm afraid, sorry guys, but I did I did this in Google Slides, and we use open source software, so we used LibreOffice as well. And when I converted it to PowerPoint, it didn't do a fantastic job. So things are a bit weird. But the basically what I'm going to do is talk about kind of a traditional software development life cycle. So you've got developers that code. They push their code into a development environment, development stage. There's some sort of thing that will build that code. You've got build artifacts, and then you want to promote those build artifacts through development stages. So I've got some sort of straightforward QA in production. You might have staging, you might have different kind of stages that you go through. In QA, you'd do some sort of testing. That might be automated. You might have automated testing. And then in production, you'll have operations that would look after and maintain that application. So what we want to do is when I'm working with our customers, they're looking to, they've already got something like that established, and they're looking to sort of improve it. And so we look at areas that they would like to improve that. So how can they better simulate production? So obviously if they're building and testing code in development and you're going through those stages, you want to test in an environment which is as close as possible to production. So that's one area. And how can we automate things? How can we start automating that life cycle so that we're going to push software through that life cycle in an automated way? So you've not got all the knowledge in a few heads. You've got that approach that you promote stuff through that life cycle in a straightforward way. And how can we introduce and inject more standardization through that? So rather than having like a Bible of this is what we do, how can we inject the standardization into the very things that we're going to be building? So really what we want to do ultimately by achieving those things is to focus more on developing that application, and it gives you more time to then innovate and drive the business, and less time to sort of worry about that infrastructure. So the sort of things that crop up to help developers and development teams do this with things like platform as a service. That's been around for quite a long time. The idea really about platform as a service is basically to abstract away and provide services that you might call non-functional requirements for your applications, so that you're really focusing on that application and not having to worry about the underlying infrastructure. You're not having to worry about like persistence, the middleware platforms and things like that. So what I was going to do is just run through some kinds of the sorts of platforms as a service that you might have seen out there. So things like kind of the ecosystem approach. So I don't know, like Google App Engine might be an example of that, where it tends to be public cloud. You've got your code. You need to code for that particular environment. So it's kind of an ecosystem. You've got a rich set of APIs that provide you with all those features and functionalities. It's great. You can get some really good scalable applications in those environments. But you tend to find that those applications then are kind of locked into that. So both from coding to the API and coding and the architecture of your application, it's kind of dedicated for that particular environment. So there's some sort of issues with that. The other thing as well is that although you will get different language choices, so like I think Google App Engine, for example, does about 4 or 5 different languages, you're still sort of locked in with terms of technology. So you've got very little control over the technology that you use within that platform. So the next platform is kind of the automated environment, where you're taking middleware components and different services, and you've got some automation that orchestrates all of that. So actually Red Hat had have got a solution, Openshift, which sort of fits into this. So the initial version of Openshift that we had does that. So it took, say like you wanted to create a Tomcat application, it kind of orchestrate all of that for you. So you could take your existing Tomcat application and then drop it into this, and it would kind of provide a capability around that. So it's okay. So you get more technology choices, you've got more control over the environment. Those environments tended to focus on front-end services, so not be very good for back-end services. But the other thing as well is that you find that there's a lack of encapsulation in terms of that, because where you get this platform, all of the applications running on that are kind of sharing the same binaries within that platform. And so doing a platform update or doing an infrastructure update is going to have an impact then on all the applications that are running in that platform. So you kind of it's pulling you back from that because of that lack of encapsulation. So the last one is orchestrated provisioning. So if you think about building virtual machines that meet the architecture of your application. And so you're having to automate all of those pieces. So we see a lot of customers doing this with, my customers are doing this with things like Ansible and Puppet and things like that. So they're creating a kind of a build tool chain which will automatically provision virtual machines within a virtual environment, and subsequently then put payloads onto that, manage that payload, and then be able to manage that through the life cycle. So that's incredible. You've got a lot of control over that. You meet the goals of encapsulation because it's completely dedicated. Those virtual machines are completely dedicated to your application. Scaling those applications can be a challenge, so you need services to help you scale them. So if you want to scale out your web tier, how do I do that? You kind of rely very heavily on infrastructure as a service, so things like OpenStack can help you with that. But also typically you tend to find that those kinds of build chains, tool chains are completely built within house. So it's not something it's not like a package you can buy that will do all of these things. You're having to use lots of different services. And so there's a big overhead in the management and maintenance of building and creating that type of solution. It doesn't mean it's not possible to do, and we see customers doing this quite frequently. But it's there is an overhead, there is an investment that you've got to put into doing that. The other thing is that running VMs are quite a costly way of running some processes. So if I've got a web tier running some web applications, static web applications, I'll see that I'm not getting very good utilization out of my resources. And so it's not particularly an efficient way of using the underlying infrastructure. So we look at how can we kind of bring together a lot of these things and have the best of both worlds. So it's the idea of, can we encapsulate our dependencies like we do with virtual machines? Can we orchestrate that whole deployment mechanism across that life cycle and have that sort of ecosystem? But can we still have the flexibility around our tooling and technology choices? So first of all, we'll talk about Docker and containers. So containers are effectively providing you with the promise to do this, in that they provide the encapsulation for those running processes. So you've got complete isolation within containers, within that runtime environment. So you've got the container is sort of constrained within that operating system, so that it doesn't misuse resources and is secure. You've got quality of service capabilities, so that you can run lots of containers on a single machine and not have one container sort of run hot and then swamp all the other ones, so that they create a denial of service. There's some kind of portability. Just a caution with that. So the container format is portable, but not all Docker runtime environments are the same, so you just need to be careful. But essentially, there's portability in terms of if you have a consistent underlying framework, you'll be able to port it across the different stages of your environment. And you're able to account that. So you've got accounting, so you've got metrics on the information in the runtime. So you're getting information about what's happening and the utilization that you're getting at a container level. So just as an aside, containers aren't like little VMs. So they're not virtual machines. They're actually processes that are running on that OS. But we put a namespace around that. So we lock that container into running in that environment. So you get file system mounts and memory mounts, spaces. It gets its own host name and things like that. So we kind of secure that within that runtime. And that means that when you start a container up, it's just running that process. It's not having to bring up a whole operating system with all of those services. So they're really quick to start up, as long as your application is, and they're much more efficient to run because they're just focusing on that. So this is where we're moving towards being able to support microservices type concept with containers. So they enable you to do a level of standardization as well. So I don't know if people have used Docker or containers before, but the idea is that you kind of start with an upstream image, and then you add the bits in it that you want. So for instance, in this example, I will maybe have a Tomcat image, so my standard Tomcat image that I want. And that, if I just run that container on its own, it's just like vanilla Tomcat. It's expecting to get a WAR file in its web apps directory. And so I can write a Docker file which does that for me. So basically, all I want to do is take from my Maven repository, I can go and find the released WAR file from that repository and drop it into the web apps directory of my Tomcat, expose port 8080, and then run my Tomcat binary file. Okay, so that's my Docker file. So when I then build that, I get a new image, and when I run that image, I'll get my application. And so that image becomes an immutable image that I can then share and then move that through that development lifecycle. But the challenges with Docker, and although Docker have got some solutions around this, is that it's difficult to kind of build this out and scale it out into actually a platform for lots of users. And so we want, what we ideally want if we're looking to create a kind of a platform for development across the software development lifecycle, is we need to be able to scale the capacity by adding new runtime environments. And we need to be able to do things like routing to containers. Developers don't want to see the infrastructure. What you really want to do is focus on the design of your application, the logical design of your application, and see that realized within that platform. And if you focus on Docker, your implementation would maybe taken down a road where you're having to work around some of the limitations that are in Docker in creating a Docker cluster. So there are some challenges there, and so Google Kubernetes provides a mechanism then which works with Docker and then will orchestrate that and create you a platform of capability. So effectively you get a number of hosts that you can easily extend, so you can add additional hosts that give you greater runtime capacity. So as your requirement to run more in your environment grows, you can just add new nodes to support that. It abstracts the networking, so it will plug in with a software-defined network. So I think out of the box they're using Open vSwitch and VXLANs to do that, so that when you're running a container, those containers are basically encapsulated and they actually have their own IP address on that software-defined network. So I can run a container. They run them in something called a pod. And that pod can then have a unique IP address, so I can go directly to that pod. So whereas if I run in Docker here and I'm running two containers and they both want to listen on port 8080, I've got a problem. Whereas if I'm running on here in Kubernetes, I can run containers within pods. They have their own IP address, and then the two containers can listen on port 8080. So we don't have a conflict, so you get this ability to scale in a much broader way. The other thing as well is that I can ask Kubernetes to scale my containers. So if I've got a web tier and I want to create a number of replicas of that, it will scale that out. And using services, I can then create a static endpoint. So imagine if I have lots of instances of something running, how do I create a single entry point into that? And so the Kubernetes services enables you to do this and creating that single entry point. Within the infrastructure, we can then label up the infrastructure as well. So with those underlying hosts, we can give those labels, and then we can kind of direct Kubernetes into the way that it does that scheduling. So if I say scale out to 100 containers, we can use the labels to direct how it might do that. So part of the work that Red Hat have done on the Kubernetes project is to help with the things like the scheduling algorithms and have things like anti-affinity, so that as you scale out, you can then scale across your infrastructure rather than putting all of your containers on a single node. So you've got application HA. And finally, Kubernetes provides a mechanism to provide persistent volumes that you can then attach to your containers. So if I'm running Docker normally, just on a native on a host, and I want to have some persistent storage, I need to create a mount point on the local host to mount that to. And if I'm running in a cluster environment, I can't really do that because I don't really know where that's going to end up. So we get into a complicated position of having to create lots of mount points all over the place to do this. What Kubernetes does is enables you, the platform admins, to define a number of persistent volumes that are available, and then developers can then say, well, when you run my application, I'd like to claim one of those persistent volumes and then attach it to my container and mount it on my container. So irrespective of where that container gets provisioned within the infrastructure, I've got a connection through into the persistent volume. So this means that you can run things like MySQL on there, and databases like MongoDB or etcd or any other different kinds of persistent storage. You can actually run that within the environment. So bearing that in mind, then if we look back at our simple software development lifecycle, and again, apologies for the conversion of the image, but basically what you've got now is your developers would then have some existing development lifecycle that created some package, and then we'd use a Docker build that would give us an image. We don't know where that image is going to go at the moment, so we need to host that image somewhere. We could push it up to Docker.io, but you might not really want to put it on a public repository, so you've got to think about what you're going to do with that image. And then we can create a Kubernetes description to say go and run that image in my environment, which is great. And then I need to promote that image through the different stages. So I haven't really got anything to help me move it and deploy it. When I ask Kubernetes to run something, to create a new pod, which is where it runs the containers, it will go and do that, and it will maintain the scale that I've defined. But I haven't got a way of saying, right, I've got a new version. Can you go and now deploy this new version? I haven't got a strategy. I have to manually define the strategy that I've got for taking the old version offline and putting the new version in there, which is obviously very important, particularly when you get down to production, that you're able to have a strategy for doing that. So, and the other thing as well is that how do I route into this environment? So Kubernetes will run a software-defined network, but it's completely encapsulated within that platform. So you need to build your own mechanisms for routing into the environment so that you're able to get access to those applications. So an area that Red Hat is active, we are contributing to both to Docker and Kubernetes. I think we're actually the #2 contributors aside Docker and Google in those projects. We're also doing work on Project Atomic, which is a core. It's like a minimized, just enough operating system, but is designed to run containers and Kubernetes. So it's a secure operating system. So that's based on Fedora, but it doesn't use Yum. So it's called Atomic because of the every time you do an update of the platform, you do it in one big transaction, effectively. We're also working on Openshift Origin, which is something which adds capabilities around the Docker and Kubernetes and adds some of those pieces that we're looking at missing. In particular, we can automate some of those lifecycle tasks that I've talked about. We've got a routing layer so that you can easily expose routes to the outside world, so you can create a route in from your external network. You've got a user experience, but it's also multi-user as well. So in an environment where you've got an enterprise environment, it's important for us to be able to provide solutions where you've got a multi-tenanted environment. And so you've got role-based access controls and things like that that sit around it. So now with something like Openshift, we're able to do a little bit more within that environment. So first of all, the developer would code, and we can actually watch an external GitHub, and so that we can run a build automatically within Openshift. So it will pull down the source code, build a new image, and then push it somewhere. And this is the next step that we've got, is that we've got ability to host the private repository. So you don't have to rely on a local Docker repository or a public Docker repository. You can have a repository which is shared within your environment. And then we have deployment configurations. So deployment configurations take the concept that we had with Kubernetes, where you can take a container and just run it, to something where you can actually wrap a strategy around that and define how you'd like to roll that out. So if I've got, say I've scaled out to 10 containers and I want to deploy a new version of that container, we can have a strategy where we bring up a new instance of that, of the container, and take down an old instance, and then do that until we've replaced all of them, and then switch the routing across. So from an end user perspective, coming in from an external route, you'd find that suddenly the application would switch to the new version. You don't get a 404 or something like that during that. So we can do this sort of blue-green deployment type approaches as well. And yeah, so we have this external exit points as well, which is HA. So you can create with your containers, you've got those building an application that presents something, and we can expose that to the outside world. So you have so you've got a route in from DNS or from your own load balancer that can go into a router, which then will HA into your applications. So that's how we can then build up that kind of life cycle throughout that environment. So how do we do on some of those questions? So simulate production. Well, now with containers, we know that the binary that we're going to run is going to be the same across all of the life cycles. So it's an immutable image. So all that's going to change is kind of the structure around that in terms of the way that you want to run it. But the underlying platform can be the same, and so you're really closely simulating your production environments across all of those stages. So we've got some real consistency in there. How can we automate across the stages? Well, Kubernetes itself has got really strong REST APIs so that you can talk to it. If you're using Openshift, then Openshift as well has got REST APIs, so you can talk to that. So if you wanted to have like an external tool, like say something like Jenkins, to manage that workflow and do a continuous delivery, you're able to do that through those APIs. And how can we improve standardization? Well, you've got the concept of the container enables you to inject standardization in there, and then because you've got more automation across that workflow, you're able to standardize across the way that you're delivering within your environment. So you're offering strong standardization approaches. But what's important is that standardization isn't at the cost of everyone having to work off the same versions. You can actually have diverse versions and diverse standards. What we often find talking to customers is that you'll have, a particular customer will have a number of different legacy applications, and they want to, they want to put that into a PaaS, and that's really difficult because they're all working off different versions of different bits of middleware. And that's traditionally been very difficult to get that into a platform as a service. And now with containers, we can encapsulate all of those dependencies within the container. And so we can still provide a standard for that particular application, and then, but also have that running alongside different versions. So you haven't got that kind of constraint anymore. So we're not going to reduce the choice then. So if you want to get involved in any of these things, probably the best place to start is Docker. It's quite good fun. I run Docker at home to run like Plex and stuff like that, so you can do all kinds of stuff with it. Google Kubernetes is when you want to start expanding it and getting involved, creating a cluster of servers and having an expandable host capacity. Project Atomic is our upstream community open source project for the just enough operating system to run a container environment. It's still early days with that, but that's worth having a look at. And Openshift Origin is the open source version of Red Hat's open source solution, which is effectively a development wrapper around that. So these are all areas that you can get involved. So that's me. That's my talk.
We've still got 10 minutes. So
Good.
fire away with questions.
So who's using Docker at the moment? Is anyone using Docker? Yeah?
I'm Paul Glasgow from Skyscanner. We are experimenting with Docker. We've got a few small workloads running on it. But I was interested to kind of give you experiences about customers or anyone you know of who's running Docker at scale in production.
So we have a customer that's came to us when we started work on our Openshift 3 version, which is the version which includes Docker. And that's exactly what they wanted to do. And they wanted to go down the road of Docker with Kubernetes. So I think it's a similar organization to yours, but based in Europe. They want to really run at scale, and they were looking at Docker and Kubernetes, but they could see that there were like some gaps with that. And so they actually worked very heavily with us on the betas and helped contribute to our to the development to help build a stronger platform. So we do have customers doing that, yeah. There's actually another customer that we have been working with in Glasgow earlier this year. We were talking to them, and they were looking at running Docker, just running Docker, and sort of seeing the challenges that you've got with just a pure play Docker provision. And so we've been talking to them about how you can run, with things like a Kubernetes cluster, being able to do more with that. So you don't, obviously I talked about OpenShift in the context of a development lifecycle. It doesn't mean that you can't run just Docker and Kubernetes, and we're actually providing solutions as well around just Docker and Kubernetes. So it's just where does it fit right within your organization? Do you want a developer experience? Do you want to be able to just run Docker at scale?
Well, I guess our interest is predominantly on reducing cycle time for developers, so that you can actually ship code faster without having to worry about all of the infrastructure.
So that's what we were trying to do with OpenShift. It enables, so from a developer perspective, you're just still writing code, you're committing code, and then you've got this whole tool chain which is sitting there and then building containers and pushing them through the life cycle without them having to kind of, how do I create a container? You don't really need to worry about that. So maybe they want to do containers, maybe they don't, but it's like, it's being able to plug in at the right level for that organization, yeah. So are you the only person that's doing containers in the room?
I think so.
Yeah.
Is there likely to be other cloud service platform operators taking?
Yeah, so both Amazon and Google are providing now container environments, so you can run containers. Sorry?
And IBM.
And IBM. Yeah, so IBM have got Bluemix. Yeah, so there's that's based on Cloud Foundry, and so you've got a container API that matches the Docker API, I think. Yeah.
Docker's on board.
Right. Yeah. So there are other solutions available.
Predominantly work with Azure.
Right. So Microsoft are doing a lot of work with Docker, and they actually have a Docker container, so you can run native .NET applications within a Linux environment, which is pretty exciting. And we were really interested to have a look at that. So we're seeing some organizations doing that, and I think you'll see that Microsoft will provide container capability within Azure platform. I expect that's going to happen quite soon.
So at the moment we're using, a number of projects are using tools like TeamCity, Octopus. Would that be seen as possibly a replacement for some of these?
Sorry, using?
We're using tools like TeamCity and Octopus for...
Yeah, so TeamCity, yeah. So you should be able to use TeamCity to kind of orchestrate like a development lifecycle, and because it can talk to APIs, then you should be able to get it to kind of move things through that lifecycle. Yeah, absolutely. It's very for me. We use Jenkins a lot, but Team Cities are kind of equivalent.
One more slightly
Yeah.
technical question. Why did Red Hat choose to, I guess, extend or implement a new scheduler for Kubernetes rather than going down the Mesos route?
No, we didn't actually. So Kubernetes has that scheduler capability in it, so it's part of the Kubernetes project.
Yeah.
But it's pluggable. So Google have said that they will look at integrating in Mesos as well. So I think that can come in as well. I think from Red Hat's perspective, we needed to have something ready a bit earlier than we could with having the pluggability. But I think the pluggability will come in, and we state in our literature that it's pluggable. So yeah, you should be able to at a point in the future be able to plug that. The intention is that you can plug a lot of these things in. So for example, the initial release of Openshift uses OVS for the software-defined networking, but we recognize that what we really want to do is get partners to be able to plug in their own software-defined networks for that, because that will give you much better performance, really, in the environment. So we're doing work obviously because we've got quite heavily working within OpenStack as well. We're big contributors to OpenStack, and so we're looking at integrating things like the Neutron networking from OpenStack into OpenShift as a pluggable software-defined network as well. So it's just as well as third-party providers.
Is it possible to run the software-defined networking and the kind of Kubernetes framework for distributing your containers on top of another cloud provider like EC2, where it already has a software-defined network?
Yeah, we are doing that. You will see performance degradation because you get your MTUs get.
So would you
chunked up.
recommend running it on bare metal?
Well, in most cases, people are running on virtualized, but I think that, and this is, you see VMware doing work around creating a container hypervisor, oddly enough called Project Photon. I don't know where they came up with that name. But because they see that you can, the underlying infrastructure for running containers will become hypervisors, and there's no reason why you can't install those on physical machines. And if you're moving everything to containers, then why not do that? Why not have physical infrastructure and get the benefits of that, rather than having lots of virtual networks sitting on the top of each other? I absolutely agree with that. Yeah. And this is another reason why we're doing work to integrate with Neutron. So we aren't sitting on top of the Neutron network, we're actually working with the Neutron network. Any other questions? Is anyone now interested in using containers in their organization? Good. Yeah. So you can get all of these projects that I've listed up here are open source, so you can start getting involved if you're interested without having to pay any money. And obviously you can come and talk to Red Hat if you're interested, and we can talk about solutions. Good. Well, thank you very much.